Hey everyone, hope you're doing well. Today we are taking a look at a problem involving middle term factorization for quadratic equations because that is a prerequisite for A-level pure math quadratics. Okay. A rectangle has a length of x plus 3 meters and a width of 2x plus 1 meters. The area of the rectangle is 12 meters squared. Find the length of the rectangle. Now, whenever I am solving a math problem, I like to write down whatever information is given to me. So in this case, the given information is that the length is x plus 3. I will ignore the meters for now. And then width is 2x plus 1. Once again, I'm going to ignore the meters unit. And the area is given as 12 meters squared. Okay. Now let's draw out the rectangle that they provided us. And we will label it with the length and the width. X plus 3 is the length and the width is 2x plus 1. And we are required to find out the length or compute the length. For that, we would need the value of x. Great. In order to find out the value of x, we would need some sort of equation in terms of x. Good thing that they provided us the area, because we know that the area of the rectangle is length times width, which is equals to 12. Now we can replace length with the expression x plus 3, and we can replace width with the expression 2x plus 1. And that product is equals to 12. You may notice that I used a dot over here. Well, that's because a dot is equivalent to a multiplication sign. However, in equations where we already have an x term, it might be confusing to use a multiplication sign. So in order to avoid confusion between the multiply sign and an x variable, I like to use dots. Great. Now I'm going to expand the brackets here. We'll get 2x squared plus x plus 6x plus 3, and that is equals to 12. We will simplify this by adding the 6x to the x to get 7x. I'm also going to subtract 12 from both sides so that on the right hand side we get a 0. The final equation we get is 2x squared plus 7x minus 9 equals to 0. Now that we've reached this stage, this is where we try and do middle term factorization. For middle term factorization, I like to approach it as follows. I break the equation into 3 parts. The first part is the coefficient of x squared that I name a. The second part is the coefficient of the x term, which I name b. And the third part is the constant. Next, I write the product between a and c, which is 2 times minus 9, which is minus 18. And then I write down the b term as it is, which is plus 7. Next, I am going to go forward and find out the absolute value of the product of a and c, which is 18. Upon doing that, I will find out the factors of 18. I'll start off with the lowest factor other than 1, which is 2. 2 nines are 18. The lowest factor for 9 other than 1 is 3. 3 threes are 9. And we can go on until we reach 1. Great. Now we're going to represent 18 in terms of 2 factors. So 18 could be equals to 2 times 9, or 18 could be equals to 18 times 1. Now note, I could also write that 18 equals 2 times 3 times 3. However, for middle term factorization, we are only going to represent it in terms of 2 factors. So I am going to remove any, form that includes 3 factors because that is irrelevant. All right. Next, we are going to explore different combinations of these numbers as our factors. So we're going to take minus 2 and minus 9, minus 2 and plus 9. We can take both of them as positive, plus 2 and plus 9. Or we could take minus 2, which we already did. We could take plus 2 and minus 9. Similarly, we can take minus 18, minus 1, and so on, until we find out a suitable factor. This, if you haven't done middle term factorization before in this particular method, it might go over your head until this point, but once we circle back, it will all make sense. What are we going to do with all of these combinations? Well, we are going to check them against the sum and the product. The sum in this instance is b, which is plus 7, and the product is a times c, which is negative 18. Now, the sum of negative 2 and negative 9 is negative 11. Is that equal to plus 7? No. So this test has failed, the first test. Let's look at this one. Minus 2 and plus 9. Do these two terms, when added together, equal to plus 7? Well, they do in fact. So they pass the first test. The second test is the product. The product of minus 2 and plus 9 equals minus 18. And they pass the second test as well. So we're going to use negative 2 and plus 9 as our factors for middle term factorization. So all of this elaborate process that we did was only to find out the two numbers that we're going to use. And this is how we used them. We're going to break down the middle term, plus 7x, into plus 9x and minus 2x. And then add the constant at the end, minus 9. And the whole thing is equals to 0. At this stage, just to be super sure, make sure that these two state equations are equivalent to each other. Because if they're not equivalent, it means you made some mistake in finding out the factor. And you have to redo the middle term factorization. We are correct in this case, so we'll go on. This step is where we take commons. Between 2x squared and 9x, we have x as common, leaving us 2x plus 9. Between minus 2x and minus 9, we have minus 1 common, leaving us 2x plus 9. And the whole thing is equals to 0. Between this expression and this one, we have 2x plus 9 common, leaving us x minus 1, and the whole thing equals 0. At this stage, either 2x plus 9 equals 0 or x minus 1 equals 0. Either of them being 0 will make the whole equation 0. So we write 2x plus 9 equals 0 or x minus 1 equals 0. X equals negative 9 over 2 or x equals positive 1. Now this is a contextual question where we're given a rectangle and we have actual dimensions. Let's test the validity of our x values. If we input x equals negative 9 over 2 into the length equation, which is x plus 3, we get negative 9 over 2 plus 3, which is negative 3 over 2 meters. Now it doesn't make sense for length to be negative, so this is not applicable. By this I mean x equals minus 9 over 2. So let's explore x equals 1. When x equals 1, the length is 1 plus 3, as the equation is x plus 3, and the length 1 plus 3 is 4 meters. And that is our answer. So in this video, we took a look at middle term factorization and a very methodological approach which minimizes the chances of making mistakes. Replay the video if you would like to go through this again. If you have any questions, feel free to reach me in the comment section below, or I will also provide my email address if you want to email me. Thank you for watching, and I'll see you in the quadratics chapter.